Alright, so let's work some examples of what we just did with our reference triangles. So you can see where to use this. So, for instance, we're going to use reference triangles to evaluate each of these problems exactly. The cosine of 2 pi over 3. Alright, so think about where we are here. 2 pi over 3 is going to be right here. Okay, so if you need to convert that back in your mind to degrees, 120 degrees basically. Okay, 120 degrees. Alright, so we need to find our reference triangle. So here's our point P, and we're going to find alpha here. So this right here is 2 pi over 3. We know this distance is pi, so pi minus 2 pi over 3. Pi is the same thing as 3 pi over 3 minus 2 pi over 3. It just gives you pi over 3. And remember, pi over 3 is the same thing as the 60-degree angle. So we know that when you draw this reference triangle, when you draw it out bigger, because I recommend that, draw it out bigger so you can see it, we know this will be the 60-degree angle, this will be the 30-degree angle. So now you can use your reference triangles to know that the long side is going to be the square root of 3, the short side is going to be 1, and the hypotenuse is going to be 2. Now, remember, this is in quadrant 2. So in quadrant 2, x values are negative, so this is going to be a negative 1. So what we know is this point P that's up here. We know point P is negative 1 square root of 3. That's finding point P from the reference triangle. Sometimes you can use point P, if given it, to go the other way as well using the Pythagorean theorem. So it can make you can find it either way. Now, so we're looking at this angle here. This is angle alpha. And we know that cosine is the same thing as A over R, or adjacent over hypotenuse. Get the hang of saying that too. Adjacent over the hypotenuse. So we're looking for the cosine of this. Cosine is adjacent. So what is the adjacent side? Hopefully you know that. Hopefully you've had some sort of geometry or trig before. This would be the adjacent side. So we know the adjacent side is negative 1. And we know the hypotenuse is 2. So our answer to this problem is negative 1/2. Our answer to this problem is negative 1/2. Okay? Very good. Alright, so let's look at another example of this. Okay, so let's look at the sine of negative 3 pi over 4. Well, because it's a pi over 4, you should automatically... The only reference triangles that are going to be in question are going to be the 30 and 60-degree angles. Which way it's flipped. Is it a 30-degree angle or is it a 60-degree angle? And how have you flipped your triangle? If it says pi over 4, you should know beyond a shadow of a doubt what that reference triangle is. If it's any kind of pi over 4, it's going to be the 45, 45, 90 triangle. So, we know sine is b over r, or opposite over hypotenuse. Okay, we know that. Now, let's draw our angle. So, we have our trusty pencil here, and so it's negative. So we're going to go negative 1 pi over 4, negative 2 pi over 4, negative 3 pi over 4. So this is going to be negative 3 pi over 4. Now, how do I find the reference angle? Well, remember, this is think of it in terms of the space we know. We know this much. We know from here all the way around to here is pi, half the circle. We know that's pi. Even though this is negative, it has eaten 3/4 of our distance. 3 pi over 4 of our distance. So if we take pi and we subtract from it 3 pi over 4, pi is the same thing as 4 pi over 4 when you get your common denominator, minus 3 pi over 4 equals 1 pi over 4. So when you get ready to look for alpha, okay, alpha is this angle here, and we know our reference triangle will be that one right there. So drawn to the horizontal axis. So we know that's a pi over 4 or 45-degree angle. Okay, pi over 4 or a 45-degree angle. So when we draw this, we know that's 45 degrees or pi over 4. This is 45 degrees or pi over 4. Well, the only one we're really concerned about being pi over 4 is that one. And so this is our reference triangle. Remember, it's square root of 2, 1, 1. But notice, what quadrant is this in? This is in quadrant 3. So our x and our y will be negative in quadrant 3. So what do we have here for our answer? Well, we're looking at this angle here. Okay, we're looking at that angle. And it's important you get the visual of this, okay? So we're looking at this angle right here. So what is the opposite side from this angle? The opposite side is that one right there. So that's going to be negative 1. The adjacent would be the other side right here. This would be the adjacent side. Okay? But the opposite side, what is opposite the angle? What is adjacent the angle? And the hypotenuse is, of course, square root of 2. So negative 1 over the square root of 2 would be your answer there. Negative 1 over square root of 2. Now, what would happen if I gave you one like this? What would happen if I gave you the cotangent of 300 degrees? Well, we're still finding 300 degrees. Okay, this problem works no differently than any of the other ones. You're still going to find your 300 degrees. So this is 180, 270, and 30 more. So right here is our 300 degrees. So we are going to drop our perpendicular so that we can find alpha. And this whole thing is 360 all the way around the circle. We just used 300 of it. So that means this needs to be a 60-degree reference angle. Okay? So when you redraw your triangle here, off to the side, this would be 60, this would be 30. So the 30 side is the long side. It contains the square root of 3. and there's our markings. Now, we know that tangent is going to be opposite over adjacent. So cotangent is going to be adjacent over opposite. So think about this. We have this angle right here is our angle of reference, okay? The angle opposite it the side opposite it would be this one. Now be careful. Don't get ahead of yourself. This is quadrant 4. The x value is positive, but the y value is negative. So that's a negative square root of 3 there. So be careful with that. That's a negative square root of 3. So that's the negative square root of 3 is the side opposite the angle of reference. So this is going to be negative square root of 3. The side adjacent is going to be this one. So that's going to be 1. So your answer, excuse me, your answer to that problem should be 1 over the negative square root of 3. Okay? Hopefully that makes plenty of sense to you. Hopefully it makes plenty of sense. Now, here's where knowing your unit circle is going to come in the most handy. So suppose I give you this. Sine theta equals the square root of 3 over 2. And I want to know what is the least theta in degrees and radians that has this angle, that has this answer, okay? What is the least theta in degrees and radians that has this measure right here? Well, think of what we have here, okay? If we're looking at the first quadrant, we have sine, which is going to be our b over our r. So our radius would be the hypotenuse of this triangle. And the b is going to be the same thing as the side opposite our angle. Or I should do theta here since we're doing theta. This should be the side opposite theta. So what angle is this? That's the question, because we're trying to find the least one. So the first quadrant is going to be the least one that has this mark. Because how did I know that? Because look, the sine, which is the y coordinate, the sine is the y coordinate, is positive. It's positive. So where is sine positive? It's positive here, and it's positive here. So the least theta is going to be in quadrant 1, not quadrant 2. So that's why I started out in quadrant 1. I don't know if I made that clear. That's why I started out in quadrant 1, okay? Based on the positive number there. Okay, so what theta has these two values? Well, think of your reference triangle. Hopefully by now you realize that this is a 30, 60, 90 reference triangle. Well, 60 is the side with 1. 30 is the side with square root of 3. So in order to have a square root of 3 opposite the angle, that would mean theta here has to be 60 degrees. Theta would have to be 60. Now, if it will vary as you go into other quadrants. I'll show you in a minute. But in radian measure, 60 degrees is pi over 3. 60 degrees is pi over 3. Okay, so what if it's in another quadrant? That should be your main question. Well, think of it like this. Here is what we have. Let's suppose we're going to find cosine of theta equals negative 1 over the square root of 2. Now, where is cosine theta negative? Well, that's where is x negative is basically what that's saying. Well, it's negative here and it's negative here. So where is the least angle going to be? Well, the least angle is going to be right here in quadrant 2. So I know that this is where my least angle is going to be. Okay? Now, because this is I can't believe I lost that. Because this is 1 over the square root of 2, because this is negative 1 over the square root of 2, here's what we know. We're looking for a 45, 45, 90 triangle. How did I know that? This is A, this is R. So think of your 45, 45, 90 triangle. Square root of 2, your reference triangle. Square root of 2 has the rate. The square root of 2 is the radius on that particular triangle. So I know that this is in this particular quadrant. I'm looking in this quadrant, and now I know I'm looking for the 45-degree angle in this quadrant. And so this is going to be a negative 1 and a square root of 2 here. So we know that 45 degrees. Now, 45 degrees is not the answer to theta. It's not our least angle. 45 degrees is not in this quadrant. So what we've got to find is, what is this angle right here? What is this angle that goes from here to here? Well, how do we find that? Well, we know the distance all the way around here is 180. We found 45. So we know from here up to here is 45. So 180 minus 45 would give us our coterminal angle, or our reference angle here. It would give it to us in terms of that quadrant. Now that's what it's doing. Let me restate that again. It's giving it to us. We found the reference angle of 45 degrees. 45 degrees is not in this quadrant. What 45-degree angle is in this quadrant? Is in quadrant 2. Well, it's 135 degrees. And that's how you find it. Now, what is 135 degrees in radian form? Well, if you hadn't memorized your unit circle, you can easily convert it using what we've learned in section 2.1 and 2.3 and get 3 pi over 4. All right, so we have 2 more topics in this section and we'll be done.